Hey there, this is Darby at Calm Math, and this is a review of the Florida State Assessment or FSA Grade 4 practice test. I got this off the FLDOE website in 2022, and this is part 2 of the practice test. I will link to the first part in the comment in the description below. So this is a paper-based test that I'm going over. There is also a computer-based test on the website that is easier for you to practice on. This is just easier for me to use in video to write on and stuff. So there is a reference sheet to make sure you can print it out or have access to it. Has conversions on it and area formulas and perimeter formula. So I'm going to scroll down real fast to session 2 because I already went over session 1 in a different video. Okay. So here we go. Which figure has a line of symmetry? So a line of symmetry is if you put a line through something and fold it in half, it would be the same on either side. And like an example of a line of symmetry, if I had a circle and I put a line down the middle of it, if it folded it in half, it would be like the same, right? Or a heart. If I put a line down the middle this way and I folded it in half, it would look like that. Now, if I were to have, like, say, a heart and draw a line through it like this, that would not be a line of symmetry because if you fold it in half, part of it would be the curved part and part would be like the pointy part, and that would not be a line of symmetry. Okay, so it kind of has to be like that mirror image of folding it in half. So the letter G would not be a line, like you could not put a line through it anywhere and fold it over each other. Same thing with the letter R. This triangle here, if you put a line straight through, pretend it's a straight line. If you put a line through there, you could fold it in half and have it like the same over here. So B would be the correct answer. This one, if you put a line through the middle there, this bottom portion would like jut up too high. If you put a line down the middle this way, same thing. This would be too high and this would be too low. So that is not a line of symmetry. So B would be the correct answer with the triangle. All right, a table shows the distances that Brianna ran on 4 days, Monday, Tuesday, Wednesday, and Thursday. Which comparison about the distances is true? A says Monday's distance is equal to Wednesday's distance. So let's look at Monday and Wednesday. Monday is 2.04 miles. Wednesday is 2.4. Those are not equal. So A is not true. B says Tuesday's distance is less than Monday's distance. So for that to be true, 2.37 would have to be less than 2.04. 3 is greater than 0. So that's not true. C says Thursday's distance is less than Tuesday's distance. So Thursday is 2 point, Thursday says 2.08. Write it over here, 2.08. And Tuesday is 2.37. So is Thursday less than? Yes, it is. So C is the correct answer. And just to check what D says, Thursday is greater than Wednesday. So let's check that out. Thursday is 2.08 and Wednesday is 2.4. And that is not true. 0.8 is not greater than 4.0. Okay, so this problem says select all meaning there's going to be more than one correct answer. Select all the equations that show different ways to represent 5/8. Okay, A says 2/8 plus 3/8 equals 5/8. 2 plus 3 equals 5. That is true. B says 5/8 plus 3/8 equals 5/8. 5 plus 3 equals 8. So this is not true. It's not even a true equation. C says 1/8 plus 5/8 equals 5. So 1 plus 5 equals 6. This is not true. Now let's look at D. All of these have the same denominators. So we're really just adding the numerator, the top number. So if we add 1 plus 3 is 4, plus 1 is 5. This is true. And E, we have 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. There's 5 ones. So E is also a correct answer. So when it says all, there's going to be more than one correct answer. So make sure you check all the answer choices. A cheetah jumps 7 meters. I almost said Cheeto. Jumping Cheetos would be really funny. A cheetah jumps 7 meters. How many centimeters does the cheetah jump? So here you could reference the reference sheet. I almost said formula sheet, but it had all the conversions on it to see how many centimeters are in a meter. So if there's 7 meters, I'm going to write M for meter. And I know that there's 100 centimeters in 1 meter. This is the metric system. So you can set up a little fraction thing and multiply. 7 times 100 is 700. So there'd be 700 centimeters. And the meter on top and the meter on the bottom are going to cancel out. And you're left with 700. Okay, what is the measure in degrees of the missing angle? So in order to solve this, you would need to know how many degrees are in a circle. So if we were looking at this like it's a circle, like all the way around. You would have to know that a circle has 360 degrees. A straight line has 180 degrees, but none of these quite equal a straight line. So how would you approach this problem? All 4 of the degrees have to add up to 360. So you could add up the 3 that we know and subtract it from 360, or you could subtract them one by one. It doesn't matter, you'll get to the answer either way. So I'm going to add up all 3 and then subtract. So we have 65, 86, and 77. So 5 plus 6 is 11, plus 7 is 18, and 8 plus 7 is 15, plus 6 is 21, plus 1 is 22. So I'm going to subtract 228 from 60. And I have 132. You should always check my work because I do make mistakes. And I don't have the answer key in front of me. And that's okay. Making mistakes is part of math. Okay, an addition statement is shown and there's a missing digit that goes in this box and they want to know what that number is. So I could look at this number and I see that 2 plus 8 is 10 plus 6 is 16. So I know that I'm carrying a 2 to get to 8 here. So that's one clue. Whatever this is has to add up. But if you don't know how to approach it, I'm going to back up a little bit. If you don't know how to approach it, then you could just start adding like you normally would. So 9 plus 1 is 10, plus 4 is 14. And then 1 plus 9 is 10, 5 plus 5 is 10, so that's 20, 0, and then carry the 2. And 2 plus 8 is 10, plus 3 is 13. So 13 plus what equals 20? 13 plus 7. So 2 plus 8 is 10, 7 plus 3 is 10, so that's 20, carry the 2, and that's our missing digit. Okay, so here we have a pattern, and I have a whole series on patterns in my Math for Fun if you like patterns. You're adding one triangle to the top, to the left, and to the right. And the first thing in the pattern is one triangle. So I'm going to make myself a little T-chart. So the first one has one triangle. The second figure has 1, 2, 3, 4 triangles. The third figure has, I'm just going to say 2 here, 2 here, 2 here, and 1 in the middle. So 6 plus 1 is 7. So here we have a pattern going, right? And we want to know, I have to scroll down a little bit. So let me erase these numbers. Okay. The fourth figure, so the next figure in the pattern will have an even or odd number of triangles. So looking at the pattern that we have, it looks like each time you are adding 3, right? You're adding 3 each time. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. So the fourth figure will have 10 triangles, and 10 is even. And if you couldn't get the adding 3 each time, you could draw it out if you wanted to. But then if you go a little bit further down, it wants us to say why it would have an even number of triangles. So you kind of have to know that you're adding 3. You're adding a triangle to the top, a triangle to the left, and a triangle to the right. So that's 3 triangles each time. So you're adding an odd number because 3 is odd. So it's not going to be A or B because those both say adding an even number. So you're adding an odd number. And the third one had 7 triangles. So you're adding an odd number to an odd number, right? Does that always give you an even number? Or does an odd number plus an odd number give you an odd number? So let's think of some different examples. If we have 1 plus 1, those are both odd numbers. That gives us 2. That's an even number. How about 3 plus 5? Those are 2 odd numbers. And that equals 8. That's an even number. So odd plus odd equals even. So adding an odd number to an odd number always gives you an even number. So C would be the correct answer. Which pair of statements represents 45 equals 5 times 9? So let's go to our math vocabulary. We are looking for multiplication, words that mean multiplication. So let's look at A. Rosie has 45 toy cars. Rosie gives, so gives is subtract. Less, she has less cars now. So that is subtract. It would have been easier to just write the subtract sign. Okay. B. It's not that because we're looking for times multiplication. Okay, B. Rosie has 5 toy cars. Her brother has 9 more than Rosie has. So if he has 9 more, that's adding, right? Add. So it's not that one because we are looking for multiplication. I'm having a hard time reading today. All right, C. Rosie has 5 toy cars. Her brother has 9 times. Times is the key word here. And we are looking for multiplication. So C would be the correct answer. And let's double check D. Rosie has 5 toy cars. Her brother increases. So that would also be add. So that is not the answer. So it's a good idea to be familiar with vocabulary and whether it means add, subtract, multiply, or divide. Times is a good giveaway that you're multiplying because you're like times table is an easy way to remember that. Okay, two parts for this question. We have long jump measurements, and there is looks like a ruler almost. And something I want to point out about this is these are evenly spaced. And let's count them up. This is 1, 2, 3, 4, 5, 6, 7, 8. So each foot has 8 spaces. Each of the lines is 1/8 of a foot. Okay, so anytime you have something with measurement and it has even spaces like this, you want to know what those increments are. So Allison jumped 3/8 of, or 3 of those spaces shorter than the farthest jump. So if the farthest jump is right here, we're going to go 3 backwards. 1, 1, 2, 3. So Allison jumped to right here. And that is the second space, 1, 2, after 4. So 2/8, 4 feet and 2/8 right there. Okay, remember there's a second part to this. Okay, the difference between the shortest distance and the farthest distance. So let's scroll back up. So the shortest distance is right here, and the longest distance is right here. So you could say that this is 1, 2, 3, 4, 5, 6, 3 and 6/8. This is one way to do it. I'm going to show you two ways to do it. And the longest distance is 4, 1, 2, 3, 4, 5, and 5/8. And then you could go through like borrowing from the 4, this becomes a 3, 8 plus 5 is 13. So 13 minus 6 is 7/8. So that's one way to do it. Or you could just count how many steps it takes you to get from one to the other. 1, 2, 3, 4, 5, 6, 7. And I also got 7/8 that way. So the cool thing about math is there's usually more than one way to solve a problem. So it would have been A 7/8. Okay, select all the shapes. Remember, if you see something like this where it says all, there's going to be more than one correct answer. So check all of your answer choices that always contain perpendicular sides. So always doesn't mean some of the time, it means always. And perpendicular is a 90-degree angle, like the corner, that's 90 degrees. So an obtuse triangle. Obtuse is an angle that is greater than 90 degrees. It's wider than 90 degrees. This will not always have a perpendicular side because you can't have an angle greater than 90 degrees and a 90-degree angle. I don't think it would. I mean, you might be able to, but it would be a very hard triangle to draw. Okay, an acute triangle. That is a triangle that has a side less than 90 degrees, like really narrow. It's possible an acute triangle could have an angle that's 90 degrees, but not always. Always is the key word. So this would not always be true. A right triangle. A right triangle always has one angle that is 90 degrees. So this is always true, as right in the name. Well, perpendicular at 90 degrees. Okay, a rectangle has sides that are parallel and all four corners are always 90 degrees. So a rectangle always has perpendicular sides. Same thing with a square. A square is basically a rectangle, but all four sides are the same. And all four angles are right angles. What about a rhombus? Maybe, maybe not. The angles might not always be 90 degrees. They might be acute and obtuse. We don't know. So there's a possibility a rhombus could be 90 degrees, but there's also a possibility that a rhombus could not be 90 degrees. So the always part is important to note here. Melvin mows a lawn. The fraction of the lawn that Melvin has mowed so far is represented by the shaded model below. So I counted up how many were this way and how many were this way. And it's basically 10 by 10. And if the length and the width is 10 by 10, it's 100 square units. So in this model, there's 100 square units, okay? Melvin will mow 3/10 more of the lawn. So it says 3/10 more, but we need it in terms of 100, right? Because it's 100 square units, not 10 square units. So if I set up a little proportion here, 10 goes into 100 10 times. 10 times 10 is 100. 3 times 10 is 30. So we need to shade in 30 of the squares, or we could shade in 3 of the rows of 10. So if I were to fill in 10 squares here, or one row of 10, here's my second row of 10, and here's my third row of 10. Let's pretend I can color straight. That would be 1, 2, 3, 4. 4 full rows of 10 or 40, right? And then this row has 8 shaded in. So 40 plus 8 is 48 squares shaded in, or 48 parts of the lawn complete. Okay, select all the expressions that have a value of 32. Again, all means there's going to be more than one correct answer. And 32 ends in a 2. So I am looking for, without going into a lot of detail, I am looking for, does 9 going into a number with 4 end in 2? No. I'm thinking of like 14, 24, 34, 54 ends in a 6, but not a 2. So kind of think of your multiples. Does 8 going into a number that ends in 9 give us something with a 2? No. Off the top of my head, I can't even think of a number that ends in 9 that 8 would go into. So 7 going into a number that ends in 4. Well, 7 goes into 14 2 times. So I'm going to go ahead and do the math with this one. 224, 7. So 7 goes into 22 3 times. 3 times 7 is 21. And we have 1 left over. Bring down the 4. 7 goes into 14 32 times. So this one is one of the answer choices. How about 160 divided by 5? Does 5 go into any number that ends in a 0? Well, 5 goes into 10 2 times. So let's check this one out. 5 goes into 160. So 5 goes into 16 3 times. 3 times 5 is 15. 16 minus 15 is 1. Bring down the 0. 5 goes into 10 2 times. So D is the correct answer choice. And 3 does not go into any number ending in 0. It goes into 30 3 times, but not 2 times. Plus 3 times 3 is 99. So it doesn't go into 100 evenly. So that's a way that you can approach this without having to do extra math. Okay, so here we have some inequalities. Select greater than, less than, or equal to complete a true comparison for each pair of fractions. Now, to compare fractions, you have to have a common denominator. So I'm going to rewrite these with common denominators. For the first set, we have 3 and 5 on the bottom. So a common denominator for both of them would be 15, because 3 times 5 is 15. And 3 times 5 is 15, so 4 times 5 is 20. And then 5 times 3 is 15, so 6 times 3 is 18. 20 is greater than 18. Now let's look at the next one. We have 2 and 3 as the denominator. So our common denominator, we could use 2 times 3 is 6. So if I said 2 times 3 is 6, then multiply the numerator. 6 times 3 is 18. I'll show you another way to do this. I just realized as I was writing it out. Okay, and then 3 times 2 is 6. 9 times 2 is 18. These are equal. If I had been paying attention, I could have been like, oh, 2 goes into 6 3 times. And 3 goes into 9 3 times. So I could have reduced the fractions and seen that they were the same number. So those are equal. Okay, so this next one, we will definitely have to get a common denominator. We could just use 4 as the denominator. So if I do 2 times 2 is 4, and then multiply the numerator by 2, 2 times 3 is 6. And then we have 7 over 4. So 6 over 4 is less than 7 over 4. Here's another 2-part question. And these are not necessarily related. Especially if you have dyslexia, you might think you're looking at the same number, but they are not the same number. So 32,084 is this first number right here. And they want to know the expanded form, which is writing the numbers out by place value. So it's not going to be A or B. So if I were to look at the 3 is in the 10,000s place, I'm just going to do this to help with the place value. Then we have 2,000, and there's 0 in the hundreds, and then there's 80. That's an 8, and then 4. So 3 times 10,000, that's both of these right here. Then we have 2,000, so 2 times 1,000. And then there's nothing in the hundreds place, so it's not this one. And then D says 8 times 10, which gives us 80, because 8 is in the tens place. And then 4 times 1. So D would be the correct answer. Okay, now looking at the next part of this question, it says, what is 30,284 in word form? And this is very similar to the other number, but the 2 is in the hundreds place. So this right here is 30,000, not 32,000. And it's not 3,000, it is 30,000. So the answer would be A. Okay, which one of these is an angle? So an angle is A. A is an angle. This one, B is a curve, C is a point, and D are 2 parallel lines. And that is it for session 2. Like I said, I will have the link for this paper-based practice test and the answer key in the description below, and also the link for the first session. If you found this helpful, make sure to like, subscribe, and share. I will be going through all of the available FSA practice tests in this series. So make sure to share it with students and parents and teachers. Take care.